All right, let's get right to it. If you're a leader who relies on data, you face the same challenge every single day. How do you make the right call when you know the data is never perfect? Well, today, we're going to tackle that head on. We're going to build a powerful consultant-grade framework for mastering risk and making much smarter decisions when things are uncertain. Let's dive in. So here's the question that keeps us all up at night, right? You gather all the data, you run the analysis, you make the call, but there's always that little voice in the back of your head, that shadow of doubt. And here's the truth, you can never be 100% certain. It's just not possible. But, and this is a big but, what you can do is get really good at understanding and managing the risk of being wrong. And that's our focus today. Okay, so first up, decision-making under uncertainty. Look, every single time you make a data-backed decision, doesn't matter if you're on the factory floor or in the boardroom, there is a built-in chance you could be wrong. Our goal isn't to pretend that risk doesn't exist. That's impossible. Instead, we're going to understand it, measure it, and then make smart, strategic choices about it. Now this is where we bring some serious clarity to the chaos. We're going to use a classic consulting principle called MEES. It stands for mutually exclusive and collectively exhaustive. All that really means is that when we look at a problem, we can break it down into pieces that don't overlap and that cover all the possibilities. And when it comes to being wrong in hypothesis testing, MEES tells us something incredible. There are only two ways it can happen. Just two. Every single possible mistake you can make falls neatly into one of two buckets.
So let's lay out that framework. It's all built around those two fundamental types of errors, what we call type 1 and type 2.
Let's put some simpler labels on these, shall we? On one side, you've got the false alarm. That's your type 1 error, also known as alpha. This is when you think you found something really important, a real signal, but you're wrong. It was just noise. Then on the other side, you have the missed signal. This is a type 2 error, or beta, and this is when something is actually happening, but your test completely misses it. You just don't see it. Okay, this little 2x2 grid, this is your map for navigating risk. It's super simple. The columns are reality, is your default assumption, your null hypothesis, true or false. And the rows, that's your call. Do you reject that assumption or not? You can see, two of these boxes are correct decisions. Awesome. But the other two, well, that's where you make an error. So let's zoom in and really understand that first one. All right, let's really get into type 1 errors, the false alarm. I want you to think of this as the error of action. It's when you see something, you act on it, you make a change, but it turns out you were chasing a ghost. So the technical term here is alpha risk. And what it really boils down to is the risk that you reject your null hypothesis. You conclude that a new drug works or a product is bad, when in reality, everything was fine all along. This is that classic false positive, and man, can it be costly. It's what leads you to waste a ton of time, effort, and money trying to fix a problem that was never there in the first place.
And this is a really, really important point. In most business settings, especially in quality control, this is the error that freaks leaders out the most. And why is that? Because a false alarm triggers action, and those actions are expensive and unnecessary. Think about it. Shutting down an entire production line, recalling a product that's perfectly good, all because you chased a ghost in the data.
So you're going to see this number a lot, 0.05. It pops up everywhere in statistics, in Six Sigma, you name it. And listen, this is not some random number pulled out of thin air. It represents a very deliberate, very conscious choice about risk. It's basically the industry standard for what's called our alpha level. So what are we really saying when we use 0.05? We're saying we are comfortable with a 5% chance of making a type 1 error. We've decided as a matter of policy to accept a 5% chance of raising a false alarm. Put another way, we're okay with being wrong in this specific way one time out of every 20. It's a calculated strategic risk. Okay, let's flip over to the other side of our grid. Section 4, the type 2 error, which I call the silent failure. If a type 1 error is an error of action, this one is an error of inaction. It's the danger that's lurking just out of sight, the problem you completely failed to spot. The formal name here is beta risk, and this is the risk that you just missed something real, a real effect. For example, you conclude your big new marketing campaign was a bust, when actually it was a huge success. Or, and this is way more dangerous, you conclude a batch of products is good to go when it's actually full of defects. It's a false negative. It's a missed opportunity, or in the worst case, a truly silent and potentially catastrophic failure. All right, enough theory. Frameworks are only useful if they actually help you make better decisions in the real world. So let's put this one to the test. We're going to apply it to a classic quality control problem. So here's a real question from a Six Sigma Green Belt exam. An inspection process rejects a product, but the product was actually fine. It was a conforming product. So the question for you is, what type of error is this? Which of our two buckets does this fall into? Think about it for a sec. Okay, let's break it down using the framework. Let's follow the logic step by step. Step 1, what's our default assumption? Our null hypothesis is that the product is good, right? The product is conforming. Step 2, what action did we take? We rejected it. The process rejected the product. Step 3, so what happened? We rejected a hypothesis that was actually correct. And step 4, what's the definition of rejecting a correct or true null hypothesis? Well, that is, by definition, a type 1 alpha error. It's our false alarm. Simple as that. So, we've built the framework. We've applied it. Now for the most important part. What's the big picture strategic takeaway? What do you really need to remember from all of this?
Listen, if you remember one thing, make it this. The goal is not to eliminate errors. It's impossible. The goal is to understand and manage the trade-offs. These two errors are like two ends of a seesaw. If you push down hard on one to reduce type 1 errors, to avoid false alarms, you will absolutely 100% increase your risk of a type 2 error, of missing something real, and vice versa. A leader's job isn't to be perfect, it's to understand that trade-off and make a conscious choice about where to set the balance.
And that brings us to the absolute core of the strategy. It all comes down to context. There is no single right answer here. There's no magic formula. You have to look at your specific situation, your business, your product, and ask the really tough question. Which one of these mistakes is going to hurt us more? So I'll leave you with this final thought. For a company that makes toys for kids, which is worse? Rejecting a perfectly good batch of toys. That's a type 1 error. And sure, it costs you money. Or shipping a bad batch with a hidden safety defect. That's a type 2 error. And it could be absolutely catastrophic, brand destroying. Now, for a different business, maybe a high-volume, low-margin one, that calculation might be completely different. The answer always depends on your context. And now you have the framework to make that choice, strategically.